suppose we've got a correlation. So here's a correlation. People who watch a lot of TV are more likely to be depressed than people who don't watch a lot of TV. So before we saw that wasn't the negative correlation between the number of hours you spend watching TV and grade point average. Here we're talking about a positive correlation. People who watch a lot of TV more likely to be depressed than people who don't watch a lot of TV. Here's a conclusion you might draw from that correlation. Therefore, watching a lot of TV makes you depressed, or can cause depression, or leads to depression. All right. Let's suppose the premise is true. Suppose the correlation does exist. Does the conclusion follow? What do you think? No? Say again?
They could be watching TV because they're depressed.
Yeah, good. This is so the point was no, because they could be watching TV because they're depressed, not the other way around. She's right. You know, people who are depressed tend to stay in a lot, not go out, sit around the house. What is there to do but watch the TV? Yeah, up the back. Right. So that's right. It's always good when criticising an argument. Now, I'm a big fan of slogans, and the one that you just gave me is one I'm going to repeat several times. You can't. It's wrong to infer causation just from a correlation, right? That's right. But when you're evaluating a particular argument, it's always a good idea to try and say something specific about it. So, what specifically could be some other explanation for this correlation? And that's a good one. It could be that the causal link is the other way around, from depression to TV watching rather than TV watching to depression. There are various other possibilities too. So, here's the slogan. Correlation by itself isn't sufficient to establish causation. So there are two things I want you to remember from this lecture, and this is the first one. This is the only thing I want you to remember from this lecture. So I'll say it again. Causation doesn't follow from a correlation by itself. Correlation by itself isn't sufficient for causation. You should get that tattooed on some salient part of your body, or get a t-shirt. Correlation not sufficient for causation. I'm going to give you some kind of silly examples of inferring causation from correlation to make the point that it doesn't follow. Consider this. This is true. In primary and junior school students, there's a positive correlation between shoe size and score on a standardised reading test. So the bigger your shoe size, the higher you score on the reading test. Right? Now, that doesn't mean bigger feet make you better at reading. So what's the explanation for this correlation? Say it again?
The bigger feet, they could be older.
Yes, exactly. The bigger children with the bigger feet are older. The real causal link has been age and reading skill, reading ability. The older children are better at reading because they've had more practice and lessons. Here's a nice example. Has anyone seen this before? It's a bit like the graph I showed you before of global average temperatures against time. Going from 1820 now to the year 2000. This one, however, measures global average temperatures, which are going up and up and up, against the approximate number of pirates in the world. And it's a negative correlation. It's a very strong negative correlation. It's going up because they've done this scale backwards. It goes down from this end. Normally you'd put the lower numbers over here, in which case it would slope down. But look, you can see, as the world gets warmer and warmer and warmer, the number of pirates in the world decreases. So, simple solution to the global warming problem, increase the number of pirates in the world. That's why we have National Talk Like a Pirate Day. right? It's cool. If you all pretend to be pirates, it will cool the world down, right? Because there's this link between number of pirates and global average temperatures. But of course there isn't. What is the explanation here? Is there one? Perhaps there isn't any explanation. It's just a fluke. Right? These things have got nothing to do with each other. If you measure any two things against time, take something that's going up, and then pick something else that happens to be going up over the same time period, then you're going to find the same kind of correlation between them. They might have nothing to do with each other, but you'll still have a correlation. Correlations or associations are easy to find. So when you have a correlation, there are various possible explanations. If A is correlated with B, that might be because A causes B. So let's take the TV watching and depression, for example. There's a correlation between watching lots of TV and being depressed. That might be because TV makes you depressed, A causes B. Or it might be the other way around. It might be because B causes A. That might be the explanation. You'd get the same correlation if being depressed caused you to watch more TV. Here's a third possible explanation. There's some underlying common cause for both A and B. Some X factor that causes both. Something like that is what we had in the case of shoe size. There's a common factor, age, which affects both shoe size. The older you are, the bigger you are, and hence the bigger shoes you need. And the older you are, the better at reading you are. So age is a kind of common underlying cause. Very similar to that is the idea of confounding, which I'll say a bit more in a minute. I do want to emphasise this last possibility. It's just a fluke. It's just a coincidence. It's because you found a correlation in a number of individuals. It doesn't mean there's any causal connection at all between them. That's always a possible explanation. There's some diagrams illustrating these possibilities in the study guide and here. So the dotted lines represent correlation and the arrow causation. So this is the first possibility. So A and B are correlated in all of these pictures. There's a correlation between A and B. Notice there's arrows on both ends. That's because correlation goes both ways. If A is correlated with B, that means B is correlated with A. But notice causation isn't like that, usually. Anyway, if A is correlated with B, it might be because A causes B, or it might be because B causes A. There might be some common cause, some X factor, that's causing both A and B. So in the case of the TV watching and depression, perhaps there's some weird, heretofore undiscovered gene that people who've got this weird gene mutation are predisposed to both depression and excessive TV watching. That would be a common cause explanation, not a particularly plausible one, for that correlation. Confounding is very, very similar to common cause, and don't worry if you don't quite get the difference, it doesn't matter too much. It's just that now we have, it's not that the common X factor causes both. It causes one of them and is correlated with the other, perhaps for some other reason. Then that's another possible explanation. I'll give one example. Well, I'll give two examples now, I think. So here's a example of confounding. Studies have found a strong positive correlation between whether a person attends religious services, so they go to church services, and how long the person lives. So, hypothesis, going to church services makes you live longer, causes you to live longer, leads to a longer and better life. Well, that's one possible explanation, but here's another one. There's another factor which is correlated with going to church and which causes longer life, which is having a healthier lifestyle. It's not really that having healthier lifestyle causes people to go to church, right? So this isn't quite a common cause, but people who go to church more often also, because they're more religious, tend to have healthier lifestyles. They don't smoke and drink so much, and so on. And that causes longer life. So that's confounding. We'd say that lifestyle factors are confounded with, mixed up with, the attending church services. So look, it might be that going to the church services helps you live longer, but you can't really tell, you can't disentangle the contribution of these two factors, the healthier lifestyles that go with it versus the going to church. I've come to call this effect the Gruffalo effect. Do you know this children's story, the Gruffalo? So if you don't know it, I have a 3.5-year-old son, so I know it very well. I could recite the whole thing to you off by heart. So a little mouse in the woods meets this creature, the Gruffalo, and the Gruffalo's going to eat him. And the mouse says, "Don't eat me, I'm the scariest creature in this wood. Just follow me around, right, and I'll show you. Everyone's terrified of me." So the mouse wanders around, they meet all these other creatures, and these other creatures run away in terror, right? And the Gruffalo goes, "Wow, that's amazing. You really must be the scariest creature in the wood," right? This is a nice example of confounding. So you've got this correlation between two things. When creatures see the mouse, they run away in fear, right? But that's not because they're scared of the mouse. It's because there's a correlation, an association. Wherever the mouse goes, the Gruffalo's following him, right? And it's the Gruffalo they're all scared of. They're all running away from the Gruffalo. Gruffalo's causing the creatures to run away in fear. I'll go back to this little example because I think this example comes from the book Freakonomics, which some of you might have read or heard of. It's quite a good book. There's a very strong positive correlation between how many books there are in a child's house and how well they do at school, academic achievement at school. I don't mean there's a correlation between how many books the child reads and academic achievement. The correlation is just between, you just go to the house and count the books. That's all you need to do. You will find that the more books there are in the house, not necessarily children's books, just more books, the better children do at school. So a mayor of a certain city in the US, seeing this correlation, decided that it would be a good idea to introduce a free book program and just give out books, increase the number of books in everyone's house, right? That will lift up academic achievement of all children, right? Do you think that was likely to work? What might be some other explanation for this correlation? Right. So more books means parents might be better educated, or at least more interested in education or engaged with it or something like that. Right. So that might explain the correlation. And so there's a kind of common cause explanation here. Parents' sort of levels of education and interest and engagement with their children's education leads to them having more books in the house, and also leads to their children doing better at school, you know, maybe indirectly. So just increasing the number of books in the house isn't going to work, because it's not going to change the true cause, which is this underlying X factor. Right? Because it still might be a good thing to do for other reasons. That's quite a nice idea, if you pick people books. And it might encourage parents to get a bit more interested, if they weren't already very interested. Read to their children more, perhaps. Let me say again the slogan that I want you to get a t-shirt of or tattooed to your eyelids. Correlation by itself isn't sufficient for causation, and we've seen why. Because there are all these other explanations. Just because A is correlated with B might be because A causes B, but it might be because B causes A, or there's some confounding going on, or a common underlying factor. Right? That's why correlation isn't sufficient for causation. I don't want to have a bit of a rant about this word linked. When you see that word used, you should be annoyed, because it's nastily ambiguous between correlated with and causes. Right? So when you read in a newspaper, research have discovered a link between insecticides and the collapse of honeybee colonies, you have no idea what that means. That might mean they've found an association between the two things, a correlation. Or it might mean that they've got evidence for causation, which is something entirely different. Right? So when you see linked, beware. Right? You don't really know what it means. Could mean correlated with, could mean causes. People will naturally interpret it to mean causes. People who read this their first interpretation will be that the researchers have discovered that insecticides cause the collapse of honeybee colonies. But that might be a serious mistake, right? Because it might be that all the researchers have actually found is a correlation. So here is a correlation. There is a correlation, positive correlation between two things. Students' inter score. Is it still called that, inter? What's it called now then? You know what I mean, right? ATA. Okay, there's a correlation between that and average grades in the first year at university. So what's the most likely explanation for that, do you think? Is it that A causes B? There's some common cause, there's some confounding, or it's just a coincidence? I haven't bothered including B causes A, right? Because that would kind of be impossible. Because your grades at university come after you've got your ATA score. I would say B. It's definitely not that A causes B, right? Your enter score doesn't cause, having a high enter score doesn't cause you to have a higher grades at university. There's some underlying factor, which is, academic ability or something like that, causing both. I would say it's causing both, which is why I'd call this a common cause explanation rather than confounding.